So what I'll do is that I'll try to provide a brief intro of this webinar, and then I'll hand over this platform to you. So far, we have about 15 participants. Okay, so I'll formally begin. Good morning, everyone. My name is Khalil Raza, and I work as a program manager at the ECO Science Foundation. ECO Science Foundation is an intergovernmental agency of 10 member countries, including Afghanistan, Azerbaijan, Iran, Kazakhstan, Kyrgyz Republic, Pakistan, Tajikistan, Turkey, Turkmenistan, Uzbekistan. So I'm the moderator for this webinar. And before I begin, I would like to make an announcement that all participants are requested to keep their mics mute all the time. And if you have any question, please put it in the chat box. We highly encourage you to please engage in an interactive discussion at the end. So we'll open that Q&A session after the lecture by Professor Mehdi. So on behalf of ECO Science Foundation and the Union of Iranian Societies of Mathematical Sciences, UISMS, I'm delighted to welcome you to our 5th lecture on series of popularizing maths and science. Today we are fortunate to have Professor Mehdi Radjabalipour. He's a distinguished professor of mathematics from Kerman University, and he's our esteemed speaker for today's lecture. So a short introduction of Professor Mehdi Radjabalipour, who is the fellow of Iranian Academy of Sciences and a professor emeritus from Kerman University. He has been also the president of Iranian Mathematical Society for many years. He has supervised more than 21 PhD students in maths, and has won distinguished and prestigious awards in mathematics from all across distinguished or prestigious institutions, including from the universities. He's been a senior associate of International Center for Theoretical Physics, and also regarded as one of the prominent Iranian mathematicians. So Professor Radjabalipour's title of talk is which one of the following mathematical concepts is more neutral, infinity or base number? It's an interesting topic, and over to you, Professor Radjabalipour, please.
Okay, thank you very much. Sorry. Yeah. I want I claim that infinity is more natural than base number, and my reasoning is what I'm going to do. Before, I would like to thank the ECO department, as well as the Iranian Association for Scientific Societies, as well as the Isfahan Mathematics House, and in particular, Professor Ali Rejali, as I have dedicated this talk to him as our tireless pioneer of mathematics education. My motivation for this talk was this book, 1, 2, 3, Infinity by George Gamow, which was published in 1947 and translated into Persian by Professor Ahmad Birashk many years ago. The title says that, it seems that to me, that before reading the book, that there may be some people who think that there are only 3 numbers, 1, 2, 3, and whatever after that is regarded as infinity. So by infinity, that's what I mean. That's what George Gamow means, in fact. So infinity does not mean a real infinity or whatever today we study in calculus or analysis, but by infinity we mean the imagination of very, very large numbers. So first, let me tell you what George Gamow has said. George Gamow, on page 3 of his book, I have just copied it here. Some explorers report that there is a tribe called Hottentot tribe in South Africa, who only know 1, 2, and 3. And if they have 4 children or more, and you ask them how many children you have, they would just say many. They can't say 4, they can't say 5. They only know the numbers 1, 2, 3. So I was wondering that if there are people who only knew 1 and 2, or even 1, or nothing. I came out that I learned that there is a tribe called Piraha. This is the people that are canoeing on the Amazon River. These are only at most 500 or 800 people living in the forest of Amazon forest. Instead of referring to them as Piraha, I would simply say that Amazon people, okay? And for Hottentot, I may say South African people. But of course, South African people are almost vanishing because they are assimilating in the other tribes or even modern people. But these Amazon people are not mixing up with anybody else. They are keeping their identity, and they actually believe that they are much happier and much advanced than what we think we are. So this is Professor Daniel Everett. Professor Daniel Everett was a former evangelical Christian missionary who was sent to Amazon for these particular Pirahas people to teach them Bible. He tried his best. At first, they were angry at him, but as you see, he is now so friendly with them that, like cousins, as the Iranians say, that they are so friendly, they look like cousins. He tried to convert them to Christianity, but one day he said that they asked him, for example, what was the color of Jesus Christ? He said that I haven't seen him. They said, how come you are talking about someone that you haven't seen him? And then they left the Christianity and back to their previous religion. It seems that Professor Everett also left the evangelism, or whatever you may call it, the missionary of the Christianity, the missionary on that evangelical Christianity. And now he is a very good professor of linguistics at the University of, at Illinois State University. Anyway, let's see his report, the Everett's report, up to the year 2004. See, he said that I started working with Pirahas in 1977. And at the beginning, I don't know what I am doing there. In the last 27 years, I have lived in all their villages for an aggregate time now approaching 7 years. So in 2004, in total, he has been with the Amazon people, but by Amazon, I mean only Pirahas, only at most 800 people, not all Amazon tribes, okay? Please don't forget that. It's easier for me to say Amazon people. Anyway, he has been in total 7 years with them, sometimes 6 months, sometimes 1 month, sometimes whatever, 1 year. In total, he has been 7 years living with the Amazon people. And he noticed that they don't have any concept, any perception of future, of past. They only see the present time. Or the immediate times of the present time, in the morning, in the afternoon, and up to, that's all. They don't know what, they don't care. They don't have in their language anything for the past terms, for the future terms. They only have the present term. So he has seen that there are children born by women in Harar, Piraha, but the husband, the father, was a trader, a passing by trader. And also he has tested the children whose father and mother are both from Piraha. And he said that there is no difference between them, since they are trained in these villages with these mothers and fathers. They all think the same way, the language is the same. And so don't think that the reason that they don't have any mathematics or they don't have any past or future times is because it's genetic. No, it's not. It has nothing to do with the genetics. It's just the training they get from the mothers. And that was his report at 2004. In 2012, between 2005 and 2012, he changed his mind. He changed his reports, his views. He realized that some of the things he has reported before was wrong, and he somehow corrected them. Before, he thought that they only know two numbers, 1 and 2. The rest are infinity. But in 2008, in 2008, he realized that. He said, I realized that the Piraha have no linguistic method whatsoever for expressing exact quantity, not even 1. They can't say that, please give me 1, or please give me 2, something like that. They don't have any conception, any perception of numbers. By 2012, he said that my total time with these Piraha people added up to 8 years. In 2012, he said that Piraha's language has so many unique characteristics. The absence of numbers, that's very important. There is no number in their language. The absence of counting and colors. They don't mind for colors, green, yellow, no, nothing. The absence of creation myths. They have no story about the creation of Eve, Adam, or whatever, or God, or so on. And the refusal to talk about the distant past or the distant future. They are reluctant to talk about their past. They are reluctant to talk about the future. So they only talk about now, about the present time. Also, it lacks the characteristic of recursion and clause subordination. These are the things, something related to grammar, and has made Chomsky, the famous linguistic, very angry at him, and they have some quarrel with each other. This is related to grammar of the language. Pirahas use the word small, large, and too large. This is what they do. If something is small, if something is large, if something is too large. That's all they know, they can say. Now, I want to make it mathematical, to state these things in mathematical terms. You see, Piraha, if they sit at the table to eat food, they just eat as much as they need. The rest, they just leave it, because they don't have any concept of future. They don't have any concept of saving for the future, saving for the next time. They just eat, and whatever is left is left. Maybe animals come and eat them. They spoil. They throw them out. They just vanished somehow by animals, by spoiling, by sunshine, or whatever. So for these people, I believe those three words, small, large, or too large, could be translated into mathematics as infinitesimal. When these Pirahas people say that it's small, it means that it's not enough for me. In my belief, I would call it infinitesimal, something too small, not enough for me to eat or to use or whatever. If something is enough, I would call it finite. And if something is too large, more than what I need, is what I call it infinite. So I just put a mathematical term for them. Let me begin with number one to see if what happens if there are people who know one. Of course, as I said, all people except for Pirahas, I think every other nation knows what one is. So let's study the word one in Aryan languages like English, French, Russian, Persian, Indian. Well, a lot of these Aryan people that you know around the world. Let us look at the root of the word one. The etymology of one goes back to the prototype Indo-European word oino. Oino is show it by me. O-I-N-O. Oino, you can see on the 1, 2, 3, 4, 5th line. And George Ifra says that there is also another word for it, oiko. Probably oino and oiko may have come from some other word like oinek. Oinek means whatever, either oino or oiko, or a more prototype word, oinek. This means alone. So the word one in Aryan languages come from the word alone in the prototype Indo-European people. Now, this word in Greek is attested by oinos, in Latin by unus, in Old Persian, in Avesta, by Ivan, in Sanskrit and modern Persian, by Eka or Yek, in Breton, by An or in Old English, by An, in German, by Ein, and in English, by one. So this word one comes from loneliness. Now, if somebody is alone, he is looking for somebody to play with. In Persian, we say duvidan ba. Now, this duvidan, or to play with, is something, a desire. You want to be with someone. Now, this word in Persian is changed to do. 1, 2, 3, yek do se. In French, like do. In English, tu. D has changed to T. Old Persian, bae, duvidan ba. To play with. This word with in Persian is bae. And this bae in other languages is changed to bai, like in binocular, binomial. So bae in Sanskrit also means two. So either two, do, or ba, bae, bai, all of them, they all mean two. Now, this one and two are somehow complementary. If God was alone, he created us because he didn't want to be alone. He wanted to be known to others. So two is something to make odds even, I would say. This is, I say, by shaf evaluat, by the even and the odd. I leave to you to translate, to interpret it more. Okay, let's go back to 2. Now, there are, if you have a, suppose you have a base number, if you have 1 as a base number, nobody uses that. This is the most useless base number, to have 1. Now, suppose you have a number 9 and you want to write it in base 1. All you have to do is to write 1, 1, 1, 1, 1, 9 times. That's the expression. So in base 1, nothing is useful. But I just wrote it to see what happens in case 2. Now, this number 2 in base 2 has 3 representations. One is the binary representation. Binary representation consists of 1s and 0s. So 9 is 1 times 2 to the power 3, 0 times 2 to the power 2, and 0 times 2 to the power 1, plus 1 times 2 to the power 0, okay? This is the binary representation, and if you want to write it in binary form, it is 1001 or 1001. I should say 1000, and anyway, 1001. This is 9. We have also a dyadic representation. 9 is equal to 1 times 2 to the power 2, plus 2 times 2 to the power 1, plus 1 times 2 to the power 0, which, if I write it in positional form, it should be 1, 2, 1. This dyadic representation is not too common, but some people use it. I don't know where or why, but that's unique, like the binary representation. There is another thing which I have called it pseudo-dyadic, but I have seen these people who are experts in Aboriginal people, in natives of Australia, natives of Amazon, natives of Africa. They call it dyadic, but I just want to say that this is wrong. Dyadic is number 2. What they call dyadic, in fact, I would call it pseudo-dyadic representation. In pseudo-dyadic representation is what in the previous slide I called odd and even, okay? You first distinguish if the number is odd or the number is even. Like 9 is even, okay? So 9 is equal to some 2's plus 1. And 1, there's only one, okay? And the rest is 2, 2, 2, 2, 1. This is dyadic representation. It is as useless as the representation of 9 by 1. 1, 1, 1, 1, 1, 1, 1. It doesn't solve any problem. It's not useful at all. But these people, expert in Aboriginal history and so on, they have called this dyadic, but I would call it pseudo-dyadic. Now, what about number 3? For those, either 3 is infinity or 3 is 2 plus 1. Which one? In George Gomov's book, Hottentots regard 3 as 2 plus 1 because they knew 3 is 1 more than 2. So for them, 3 is 2 plus 1. But for the our Aryan ancestors, 3 is infinity. 3 was not 2 plus 1. Later, of course, they changed their mind. But at the beginning, they had only 1 and 2, and they were happy. But 3 was just infinity. The etymology of the English word 3 goes back to the word trong. You see the red words? Trong, meaning a large number. This is still common to many Aryan races. Trong of people in English or trunk of water in Persian. Maybe some Persian people say that we haven't heard it, but if you come to Kerman, in our villages, you will see that the use of trunga ab, which we call abshar. We call it trunga ab. It is believed that the English tree, the French trois, the Persian se, and the Sanskrit Old Persian tree, traya, tisras, all are derived from trunk. Therefore, the original meaning of the English tree was not 2 plus 1. It was infinity. If the Aryans at those days, prehistoric time, not now, if they were 2 and had a child, then they would say, oh, we are a lot. They couldn't say we are 3. They would say we are a lot. We are infinity many people. Now, let's go to Australia with native people of Aboriginals of Australia and see their pseudo-dyadic system. Some of the Australian Aboriginals used the pseudo-dyadic system and counted beyond 2 and 3 in a recursive manner. Recall that Piraha people had no notion of recursion. The next 2 slides show Australian Aboriginal ways of counting the first counting. The first one, let me bring the one. See here, this is a tribe, some Aboriginal people living in Bourke, the Darling River of Australia. The numbers they know is Nika, Nicha, Bula, Bula Nicha, Bula Bula. If I translate them into English, would be 1, 2, 2, 1, 2, 2. This looks like a chanting. Probably these people are chanting that song. 1, 2, 3, 4, something like this. But of course, the picture, I just got it from somewhere, and the chanting is from some, these numbers are from another book. I mixed them up. Sorry if they don't match. Here is another tribe who go up to 6. These are people from Gulmugal in Australia. They know 1, they know 2, they know 3, they know 4, they know 5, they know 6, and after that, everything is called infinity. Of course, they don't say infinity, they say Ras. The white writings, the writing in white on top of the picture, you will see these people are chanting. I think they are chanting, but this is their numbers they know. Urapun, Okoza, Okoza Urapun, Okoza Okoza, Okoza Okoza Urapun, Okoza Okoza Okoza, and whatever after that is Ras. The translation into English is 1, 2, 2, 1, 2, 1 it means 3, okay? 2, 2 means 4, 2, 2, 1 means 5, 2, 2, 2 means 6, and infinity. Whatever is after that is infinity. So this tribe is like those George Gamov's Hottentot tribes of South Africa, who would say 1, 2, 3, infinity. But these people are more advanced. They say 1, 2, 3, 4, 5, 6, infinity. So you see that here, you may say that, oh, come on, these people of Gulmugals, they had a base of 2 before they reached to infinity. First of all, I will say that this is not a binary system. This is not even a dyadic system. This is a pseudo-dyadic system. This is just like writing a number in base 1. If you want to write 5 in base 1, you have to say that 1, 1, 1, 1, 1. But I wouldn't mean that, because that's not a useful base number system. So I wouldn't regard this as a base number. So I don't know why it is going back. It's going back. Oh, sorry. Oh. Okay. So anyway, the way these Australians, the native Australians were going, you see that these people are not really using base 2. That's a pseudo-dyadic system. Anyway, in some parts of Australia, Aboriginals decided to stop their pseudo-dyadic counting at 4 and accept 5 as the number of fingers on the one hand. See, these people were saying that 1, 2, 2, 1, 2, 2, for example. And some of them would stop there. But some would go up to 2, 2, 2, which means 6. But anyway, that wasn't a good way of counting. And they decided to choose 5 as a basis. Now, these people who chose 5, you may say that, okay, what was infinity? Of course, these people had already chosen 7, 8, 9, whatever after 6. They are chosen at infinity. So the concept of infinity was a little earlier than the concept of basis. Here in the lower paragraph, you will see that a tribe called Martu Wanka people. They stopped at 4 and continued in base 5. You will see Kuja is 1. Kujara is 2. Kujara Kuju is 3. Kujara is 4. See, so far they have come with pseudo-dyadic. You may call it base 2, but that's not really a base 2. But then they stop this base 2 business. They will say Mara Kuju, which means first hand. And first hand means 5. Then go to 6, 7, 8, 9. I have not written them. Then say Mara Kujara, which means 2 hands, second hands. So you may find some tribes in Australia that they did not use this pseudo-dyadic system. They would go up to 5 with 5 different names, not related at all. Like you will see this on the 4th line, you will see 1, 2, 3, 4, 5, and 10. The words are not related to each other. Kudji, Boken, Danjbik. And you will see at 4, they are really going upward hill. They are breathless. Kun Karangbak Menk, for example. Sorry if I cannot translate, I cannot read Australian. I apologize from the Aboriginal people of Australia. And one hand was Kunbit Kuji, and hand 2 was Kunbit Boken. Of course, Kuji and Boken are already used as 1 and 2. So this means that they are at the base. Base is 5, and then then the second 5 is 10, and you will see that. Anyway, let's rush for the. Now let's go back to Aryan people, our people. For a long time, they could not count up to more than 2. 1, 2, that's all. Ashraf of Al-Bad, as I said, just 1 and 2. Anyway, at certain point, they realized that there is 3 people is different from 2, from infinity. So the word 3 that they had, they attributed it to 3, the actual 3. And they continued to recognize 4, 5, 6, 7, 8, 9, and then they got tired. Then they chose the base 10. And then after that, 10, so they could count the last two lines, 1, 2, 3, 9, 10. And after that will be 10, 1, 10, 11, 10, 2, 10, 3, 10, 9, 2 tens. So that's what you all know. Now, there are some examples from Sanskrit and Persian that what is 2 times 10. 2 times 10 in Sanskrit is Dvi Dasati. Dasati this means hand, dust in Persian, Dasati. Dvi Dasati, 2 hands. And this Dvi Dasati is somehow polished into Visati. D is dropped, 2 D's are dropped, and it's become Visati. And then now Vimsati. Vimsati in Sanskrit means 20. In Persian, 2 times 10 was Bidasati. Bidasati, B by means two hands, and it was abbreviated or polished into Bisati, and now we say Bist. Okay, let's go back to now go beyond. Suppose we have base numbers and we want to see where do we stop? How large our ancestors would go? Here is a number called beast number, which was invented or found by Archimedes, and that was a very, very large number because at those times they would say that the sands on the beach could not be counted, but Archimedes, by this number, wanted to show that no, for anything you have a large number. This is now more advanced people. Let's go to Egypt. Do they have large numbers? Yes. In 3000 before Christ, BC, what you see on the right-hand side is a painting on the wall. Of course, this yellow and blue and whatever you read, you see, is my painting. I don't know what was the original painting. So this want to say that 400,000, you see how advanced now human being is. Egyptians can count 400,000 cows and 1,422,000 goats. This is what they say that. In fact, Indians could count more and more. Here you see that at the end of the 6th century after Christ, this is very close to Khwarazmistan. Jina Bahadragani from India produced the number, this number, you will see that, 224 billion 400 million. Yeah, 5 minutes. And would read it as this: 22, 44, and 8 zeros. So this means that he knew what 0 is, and he knew what the large numbers are, but of course he could not write it yet. He could only spell it out. Also in Egypt, this 1 million, you see the sign, there is showing a man raising hand to God, and nobody knows that whether it is really a million or more than a million. Probably million for them was just like infinity in George Gamov's book. Okay, let's go to back to Central America, to Mayans doomsday. Here I want to say that, see, let's review what we said so far. People started counting, except for Pirahas who are still avoid counting. But the rest of the human being, on at least we know, they started counting by 1, and then 2, and then 3, and then 4, 5, 6, so. When it became, they have to invent many words for these numbers. So to stop that, because how can you memorize all these words, all these names? To stop inventing or putting new names, they brought base number. So like 10, then 100, then 1,000, and so on. So between 1 and 10, you only have 10 names. And from 10 to 100, you have nothing new. Like 30 means 310. So there's nothing new. It's a very easy formula. But only 100 is a new name. Now from 100 to 1,000, only 1,000 is new. In between, there is nothing. So that was the situation in most countries. But if you go to Central America, again, back to Maya tribe, to Maya people, Maya, in fact, civilization, that's a very, very important civilization in Mexico. Or Mexico, sorry, whatever. By the way, this picture is, I was there and I took this picture, so that is my own copyright. And I believe Ali Rejali has to pay me for that picture. Anyway, sorry for it. I'm joking. These Mayan people started counting by their hands. When I say Maya people, we have to be very careful. There has been some tribes before them called Olmec, and there were some tribes after them called Aztecs. All these people, please forgive me if I am not precise about them, and let me call them Central Americans. That's easier for me, whether Mayan or if I say Maya, you think of all these people who live in Central America, okay? So some of these people, very, very prehistoric time, back to the prehistoric time, they would start counting. I don't know why. They would count up to 5, but 5 wasn't enough for them. They extended this to 10, and somehow they extended it to 13. It's possible that this 13 was, I don't know, what was that? There was some religious idea behind it, some beliefs that they would stop at 13 instead of 10. So they had a kind of base 13. But this 13 was not a base. That was a doomsday. It means that if they start from 1, go 2, 3, 4, 5 to 13, the 13th day was the end of the world. And they have to see if God would allow them to live another 13 days, another 13 days, another 13 days. Anyway, this 13 later on in some other tribe was changed to 20. So they would start from 1, 2, 3, 13, 16, 17, 19, 18, 19, 20. So 20 was the doomsday. Doomsday means the day that the world would end, would demolish, would be finished, and God wouldn't allow to continue the life. So on the 20th day of their calendar, they would go to the temple, pray for God, not to demolish the wall, not to stop life, and let them live longer. And of course, probably they have to give donation to the temple. It's not so easy. Anyway, with the prayer that the priests would do for them, and they themselves also would join the prayers, the life would continue another 20 days, another 20 days, another 20 days. So probably these were some kind of belief. So when you, every 20 days you see nothing happens, then you would gradually lose your faith in that kind of religion. So the priest decided to change, to combine the two calendar of 13 and 20, and to find a calendar of 260 days. So these two calendars would go forward, parallel to each other. When the first calendar 13 comes, doomsday is there. But there is another calendar which is going to 14, 15, 16, 17 to 20. So the world would continue to exist. But at 20, another calendar had started 1, 2, 3, 7. The first calendar, which ended at 13, started to count 1, 2, 3 up to 7. So when these two calendars meet at 20, the one is 20, which is the doomsday, but the other one is 7. So by this calendar, the life would continue. So it is after 260 days, which is the least common multiple of 20 and 13, that the doomsday would occur. So now there is a nation, whatever, the same Mayan or Olmec or Aztecs, whoever, they believe that after 260 days, the world may end. If you want to continue that, you have to go to the temple and pray and so on, so on, so. Anyway, the priest decided somehow to change these 260 days, and by adding another calendar. That calendar is the calendar we have these days, the solar calendar, which has 365 days, only 365 days, because Mayans had no fraction. We say 300, in Iran, we have 365 days plus a quarter of the day or something like that. But Mayan only had integers. So now they have 3 parallel calendars. If you want to see when the world would end, it would be after 52 years, because 52 years is 18,980 days. And that's the least common multiple of 20, 13, and 365. So every 52 years, now is a very big gap. People would gather at that temple which I showed you, that pyramid I showed you. They had a lot of them spread in Mexico, in Mayan land. Anyway, they would gather there. The priests and the astronomers, usually priests and astronomers were the same, are on the top watching the sky to see when the special star passes through the meridian. If that star passes through the meridian at 12 midnight and nothing happened, this means that God has forgiven them and the life would continue for another 52 years. I read somewhere that the first thing they do is they bring the king and they sacrifice it for the god and cut the head and throw it among the people who were chanting downstairs and celebrating the new life. And of course, king was very happy to be sacrificed for God, of course. It wasn't, he was not angry with that. Now, maybe some kings were not that happy to see very soon they are going to be killed, to be sacrificed for God. So they probably bribed the priest, they did something, and they changed this gap. They brought a fourth calendar. The fourth calendar had made a very big gap. The gap is 5,125 years. So probably the king was very happy. Any king which was made this, gave this bribe to priests to change the calendar. Now, the last doomsday was the year 2012. You remember? All the everywhere they were spreading the news that on 21st of December or something like that of 2012, the world will end. The world will end, but of course didn't. And no king was killed at that time, because Mayans were not in power at that time anyway. So, true or false, Mayans have inherited three types of calendars. That 13-day calendar is vanished. We don't know anything. It's not left. But that 260 days calendar is remained among the Mayan. They observe it. They use it for the religious activities. There is another with 52 years. Probably nobody cares about it these days. And there is a third one, which is 5,125 years. I think they just kept it as a tradition. And I think Hollywood and all these movie makers, science fiction movies, they are fond of this doomsday. They make films out of it, they make stories out of it, and they make money out of it. Now, let me look at these tables here. The right-hand side is the numbers they are using by Mayan, 0, 1, 2, 3, 4, up to 19. And if we accept this, we have to believe that Mayan used 0 from prehistoric time, but that's not true. That's something which I oppose to that. On the right hand side, you see it continues. It goes up to 19. The left hand comes up to 19, but the right hand continues probably to that longer, that 52 years of, no, that, sorry, 260 days. I have not written all of that. Again, here you will see that the sign 0 and the sign 20, sign 0 and sign 20 are shown, are almost the same, except 20 has a dot on top. The dot on top, which is, I don't know how to, you see on the left side, on the right side, look at the two rows, the lowest two rows, 20, 21, 22, 23, 24. The dot on the first row means 20, and the dots on the below it mean 0, 1, 2, 3, 4, and so on, up to 29. You'll see. Anyway, if these are new things. These are not the old ones. If you can't find them in the old stelas or antiquities, monuments, and so on. You cannot find them. In the monuments, you find the things you see here, like 13. 13, you see, there are three ellipses, 3 marbles, whatever, and 2 vertical lines. So this each vertical line is 5. So 2, 5 is 10, and 3 marbles, each marble is 1. So it is 13. And look at the one below 8, below the lowest one, 8. 8 has 1 5 and 3 ones. And look at on the right-hand side, 4. You see the figure 4. 4 has 4 ones, that's all. Now, there are 2 more which are called zeros. 0, they don't have these lines or bars or those markers. So the zeros have nothing. But instead, all of these have a picture behind them. Like behind 13, there's a picture, a face. And behind 0, in front of 0, there is nothing, you see just a face. And on 8 also you see something like face or whatever, I can't recognize it. And 0 on the right-hand side, you see a face. And 4, you see also a face somehow, maybe an astronaut or whatever it is. Now, the point is this, this is my theorem. Mayans did not have 0 at the beginning, and what is claimed to be 0 was originally 20. Either 20, and I forgot to write, either 20 or 13. You see, the common thing between 13 and 0, you see, there are 3 pictures which are either 13 or 0 or 0, 3 of them. You see, all of them shows a face with a hand touching the face. This is a sign of doomsday. A sign of doomsday. So that shows that calendar of 13 days, you recognize there is a hand under the chin, sometimes over the chin. So it's always a hand over the face. In different pictures, different artists have changed the position of the hand. But all of them have one thing in common. There is a hand touching the face. This is somehow afraid of seeing the world is ending up. So I want to use this. Of course, I don't have time. My time is over. All these 13 and 00 show that those 2 zeros also have to be 20. And by the way, the Mayan people who could not count beyond 20, at a stage, they could count. See all these numbers you see before the Spanish come and ruined their civilization in Central America. They had very, very high mathematics. Look at the last row, which is 23 billion 40 million days, or 63 million 80,082 years. Their calendar was so accurate, was so precise, that it's nobody can believe that. The people who started by counting up to only 13, some later up to 20, later up to 260, and much later up to 52 years, which means 18,000 something days, now can count these many days and years. Thank you very much. If you have any, I think my time is over. Yeah.
Thank you, Professor Mehdi, for such an interesting talk. I think I need to admit that this was our 5th webinar, and this has been the most exciting and interesting as well. Thank you very much. Thank you very much for It's not just the maths, but it's the history, it's the civilizations that you talked about. And we have a question in the chat box, and we'll also encourage other participants to please. So if you allow, I would read out the question that we have been put it in the chat box. So this is from Mr. Ali Reza Desheri. So he says, thank you for the lecture. And he continues with, don't you think translating more than enough to infinity going to distort the meaning of mathematical infinity? It continues. There is a similarity, but it's more like a physical form of infinity, not mathematical. For example, 10 meters may be a physical infinity for concave mirror, or black holes may have an infinite density compared to everything else, but they are not mathematically infinite. The base definition of infinity in math means it is more than everything you can count, and not it's more than a number. It seems like phenomenologically, the physical infinity is very similar to the numbers. It is mathematically reachable, but our physical instrument can't reach it. But mathematical infinity is incountable in its substance. So I think term you use as infinity is not a real infinity. It's a different side of counting, a different face of numbers. His question is long, but you may, if you need further clarity, I can read it out. But over to you, Professor Mehdi.
Sorry, my ears are not good enough to, sometimes I try to open them, but I don't know, I have catch a kind of cold that they don't listen. But anyway, I think what Mr. Aliza is asking me, is telling me, is that my infinity, the infinity that I am talking is not the infinity which is in mathematics, of course. Is that what he meant?
He says that
I want to just say that how people of the antiquity, of prehistoric time, and even now in aboriginals, think of large numbers, think of infinity. That's what I meant. That's what I want to say, that how numbers advance to become more, to come more into the light, like 1 and 2, and then 3. 3 was infinity for Aryans even, which now the ancestor of all European, Iranian, Indian, and all these people in the Central Asia who are from the ancestor, and even Turkish and all these people who use the base 10, they were close to each other, and they sometimes they knew only they could count up to 1 and 2, and 3 was for them was infinity. This I understand from the language, the etymology of the word 3. But in South Africa, you will see that they could go up to 3, and the explorers of South Africa, they noticed that they cannot go beyond that. This is what I really wanted to talk about, how human beings develop the numbers, they gradually got the concept of numbers, and they reached, they bypassed the infinity and reached the basis of the number system. And upon that, they made larger and larger and larger numbers. At the time of the Plato or Socrates, some people were thinking that infinity is a number, it might be on. But of course, Plato would say that you can go as large as you like. You can claim as large as you like, but you can never say infinity is a number. That was okay. That was what today also in ordinary mathematics, we believe that infinity is not a number. But you can approach you can make larger, you can choose, you invent, as Archimedes did it, larger and larger and larger numbers. So I really didn't mean that this infinity is really infinity, is something. This infinity is nothing. It's just imagination of the human being, of the numbers, of what up to where they can count and where they cannot. Where they cannot count is infinity for them. I remember I read somewhere that like Indians, they had a very large number, which would say that you can count up to this. Of course, that's not true. You can always add one to it. And I will also, I want to also talk about infinitesimals. Infinitesimals, how small you can go. For example, in Egypt, in prehistoric time, they wanted to divide bread among the laborers. Okay, if you the easiest way to divide it is to halve it, to halve the bread. It was a circle. You could easily make it into half circles, and each half circle could be divided into another quarter, and quarter to and so on, so on, so. But the thing is this: when you reach to 1/64 of the bread, then if you divide it into 2, you will get 1/128. That was too small, and they would regard it as 0. So 1/64 was infinitesimal for them. So this came to their belief, this came to their religion. They could not go beyond that. Egyptians could not go beyond below 1/64. So this was their infinitesimal. Now, in Greece, they believed in some atom. But of course, Plato would not believe in it. He would say that no, anything can be again divided into 2 pieces. There was a fight between atomic Democritus and non-Democritus and the people against him, that whether you can continue this bisection up to, or you can stop, or you may stop, you will be forced to stop at somewhere. So this is another way of going down and down and down. The interesting thing about Mayans is that they had no fraction. They could not go into infinitesimal. They did not have even half of the half. But very interesting is this: they could say that, for example, if a lunar month is 29 days, 0.005, for example, by our calculation, they would multiply this number by some integer to make it to multiply an integer to make it an integer. Like suppose you have 2.5. Mayans didn't have 2.5, but 10 times 2.5 is 25. They would say that after 10 times repetition, you get 25 days. They wouldn't say that in one occasion you have 2.5 days, because they didn't have half a day. But they would say that if you repeat this phenomenon 10 times, you will have 25 days. So anyway, this is probably I didn't hear what this gentleman said, what you said about this gentleman view. My ears are not good enough today, but I guess that he was saying that the infinity I am talking about is not the infinity that mathematicians like it. But this is about the history of mathematics, about the history of the prehistory of mathematics.
Right. Professor Mehdi, so I understand that you clarified this point on spot in terms that you put that a framework where some of the ancient civilization were not even three was the infinity for them. So uh, it's a state where that civilization or human being cannot count beyond that point. So they call it infinity.
That's right. Yes.
And
Yeah.
and I understand that concept quite clearly. So as with the computation models that we have and the technology infrastructure, so we will have more than enough, or our computation capabilities would continue to increase, and in a sense, and so we'll be able to explore the physical aspects of a universe in much more detail, and hence we'll be able to calculate, we would be able to read the numbers as much as possible with the computation. So do you think that, for instance, this Mayan large number was billions, so and our civilization would continue to add on, so the maximum number that we can count?
Uh, of course, our computers are expanding day and they are advancing every day. They do very, very long calculations, very heavy computations. There's no problem with that. I'm sure there is no end to it. I don't believe that the numbers would end somewhere, of course. So I don't think that we ever reach to a largest number. There is no largest number.
Right.
Yes. Unless you may think in the universe. In the universe, there is a limitation in the universe. That's something physical. I don't know. I don't. I can't say anything about it. That the limitation of the universe, the limitation of the physics. I really don't know anything about that. I only talk about what people were thinking of. That's all.
Right.
I don't know what really what there really is. I think what people were thinking, how our mind was developing in the perception of numbers, in the realization of mathematics and arithmetic and things like this. I have no claim on physics, on
Okay.
things which are related to mathematics on my subject.
Yeah, fair enough. So I understand. So we'll take one last question from the comments or the chat box, and then we'll conclude. So this is from Payam Siraji. He says that in the book 1, 2, 3, Infinity,
Yeah.
Gemov says that in contemporary mathematics, we usually use only three kinds of infinities: countable infinities with cardinality aleph 1, continuum with cardinality aleph 2, if we assume continuum hypothesis, infinities of cardinality aleph 2. So our situation is not very different from that of African tribe that can count only up to 3. What do you think about this?
I was only concentrating on the type 1, which means just integers. Integers is a set of infinity, is an infinite set, and it is a discrete set, and it's countable. It's countable. All I was talking was about countability. I agree with other type of infinity, cardinalities. All there are more. In fact, if you want to each cardinality to take it as a type of infinity, so you have infinitely many type of infinities. But all I was talking about was the simplest infinity. In fact, I was only talking about large numbers, really large numbers, not infinity. that was the imagination of human being of large numbers. When they couldn't count it, they would call it infinity, too many. I was talking about too many. George Gamow says that if you ask a Hottentot people that how many children you have, if he has one, it would say one. If he has two or three, it would say two or three. But if he has 4, 5, 6, whatever, if he just can't say anything, he would say many. Or this Everett, who was working with Amazon tribe, they asked him if somebody wants 2 eggs from his neighbor, how does he ask it for? He said, I lived with them 8 years, but believe me, I don't know how they say it. How they say it, please give me 2 eggs. Yeah? Maybe he just goes inside the house and takes 2 eggs and said, this, I want this. he living there, and he is probably the only person who knows their language. As at least in the article I read, he was the only person who knows the language of these Piraha people. And he still doesn't know how they ask for 2 things, for 2 apples, for 2 eggs, for 2 whatever. So this is what I was thinking, mostly educational, pedagogical. I was thinking on that way rather than mathematical, abstract, pure mathematics. No, I was really thinking how children, how our ancestors, how a beginner understands the numbers, and how he tries to overcome this difficulty of counting. Things like this. I mean, my aim was mostly educational, pedagogical, rather than historical. Of course, historical was there. History and pedagogy and mathematics and history of mathematics are mixed up. But I was not thinking about pure mathematics. In pure mathematics, whatever I said would be nonsense.
Right.
Confess.
Thank you, Professor Radjabalipour, for this very exciting and interesting presentation and lecture.
Thank you very much.
We are truly grateful to you for your time, for taking this time to you, and also providing this opportunity for audience to learn about this aspect of mathematics. And I think with the questions that we have received, we can truly say that your talk has been very engaging, and we have also recorded it. So we'll put it on our website and our YouTube channels as a recorded session, and we'll also provide you the link with those who are interested. So we continue to have and host this one lecture in a month, and we were grateful for your participation in that. Thank you to Professor Jali as well, the UISMS, and we would continue our work in terms of promoting science and maths through our expert series lecture. Thank you, everyone, and have a great day.
Thank you.
Bye-bye. Thank you.
Bye-bye.
Khuda Hafiz.
Khuda Hafiz. Destiny.